So the next speaker from Finland, it is my pleasure to invite Marikka Heikkilä, Research Director at the School of Economics at the University of Turku, Finland, to present Smart Fairways, co-design of future fairways in Finland. Please join me in welcoming Marikka.
Hello all, it is my great pleasure to present you our study on smart fairways, co-design of future fairways in Finland. My name is Marikka Heikkilä. I and my two co-authors, Jouni, Saarni and Jukka Heikkilä, come from University of Turku, whereas Heidi Himmanen works for Traficom Finland. Digitalization is taking big leaps in maritime with an aim to creating more efficient and sustainable transport. Recent years, innovations are created from technologies such as cameras, lidars and AI-based simulations, and so far most interest has focused on development of autonomous ships and digitalization in ports. While all this development towards digital and autonomous maritime is taking place in other areas of maritime, there has not been much changes in the waterways itself, the channels approaching harbours. Our collaborative research project is taking up this challenge of development of future smart fairways in Finland. The goal was to define the elements of the future fairway that would improve their safety, efficiency and sustainability. The objective of this research was to define the elements of the future fairway, that is the essential physical and digital services and infrastructure that help to improve transport safety, efficiency and reliability, as well as to reduce climate and environmental impacts in fairways. We defined fairway as a harbour approach channel designed for safe navigation of vessels. It is used by various vessel types ranging from commercial ships to leisure boats. Typically, fairways are governed and maintained by governmental authorities, but several of the services are provided by state-owned or private companies. For this purpose, a research consortium was established consisting of the authorities, maritime service providers, technology service providers, and universities. Together, these actors covered the necessary knowledge of the current fairways and related services, but importantly also shared the forward-looking attitude. We utilized Delphi method, which is one of the most popular techniques for technological forecasting and prioritizing issues for managerial decision-making. The study proceeded in several phases. First, pre-information collection phase. Experts responded to a questionnaire asking to provide their judgment, which is the primary target group, and what improvements should be achieved with the smart fairway. Then, semi-structured interviews of the experts were conducted to get more in-depth understanding of the current fairway system and services and development work that is related to the maritime transport and fairways. Second phase was about workshops. An initial list of future fairways elements was extracted and agreed together with the Finnish Transport and Communication Agency, Traficom, which is an authority responsible for setting the Finnish regulation and rules for the fairways. A Delphi workshop facilitated by Traficom was organized as a Teams meeting where experts were divided in 3 groups. These groups used my report to comment on and add the list of elements. They also provided their views on the importance and challenges related to each of the elements. The result from the workshop was plotted by the researchers in a diagram where x-axis shows the level of challenge and the y-axis the level of importance. Last was the Delphi verification phase. Here the diagram and the mirror board was sent back to the experts for review. Several comments and suggestions were received from the Traficom in a separate meeting and by email from the other experts. Final version of the diagram was constructed based on the comments. Here you can see the results from our study. The experts recognize altogether 22 different elements of future fairway. They are divided in color-coded 6 groups. The first is the infrastructure, then fairway information, weather and sea state, navigation and seafaring services, port arrival and departure related services, and other elements. Now then, if you look at the diagram, it shows how important the experts considered each element and how much there are challenges in developing these future services. Let's have a look at the upper right corner here. It shows those elements that were considered as highly important but also as highly challenging. Out of the 22 elements, 7 are located in this corner, and you can see from the colors that they represent different element groups. For instance, the gray number 2 is the communication systems. It includes the radio, mobile and satellite systems that support the communication in the fairway. And then there are green 8, that is the weather and sea state information, that is the observations, forecast and warnings for a certain location. And then, for instance, the ability to foresee the availability of port services, as well as information on other ships and their movements close to the planned route, and different kind of support for emergency services. All these were considered very important and also with high challenge. Then there was also the remote pilotage that is actually being developed and tested in Finland at the moment. And last here is the shared situational picture that is still under, needs quite a lot of more research. I will end my presentation with a summary. The future fairway includes elements concerning smarter infrastructure, fairway information, weather and sea state, navigation and seafaring services, port arrival and departure related services, and other such as search and rescue and environmental services. There will be several levels of smartness in future fairway phase, and so that the fairways will be utilized in different combination of these elements. Next step of our research is to define the levels of smart fairways. Thanks for listening.
Thank you, Marikka. The floor is now open for questions.
Hello, Thomas from MPA. I have one question on the future communication infrastructure. The essential ones that should be put in place for the future smart fairway to enable use cases like remote pilotage and some of the other use cases like port call optimization. Do you have any comments on that?
Yes, thank you for the question. We have been looking at all these communication media, so radio, mobile, and also discussing about the use of satellites. So we really need all of those for the fairway. So, but I'm not an expert in these areas. So maybe if you want to hear more, I can ask my colleagues to comment on you later.
Yeah, no worries. Thank you.
Hi, good morning and good afternoon. So I'm Louis from ABS in Singapore. I think this is a good research. So I have two questions. The first is, has there been a gap analysis done between what you're proposing to be the smart fairways of the future and how are the current fairways? And the second is, would this research be easily, done and applicable for the case of the Port of Singapore? Thank you.
Yeah, about the first question regarding the gap between what we have now and what we need to have. Some indications you can see from the XY diagram showing the in a way the challenge part. So the more there we see there is a challenge, the more there, the less the current services are enough for the fairway, smart fairway. But we are continuing with this actually just at the moment, digging more deeper in each of these 22 elements and looking at what we have now and what are the exact development needs in each of the elements. And also how to govern all these together. So that's also a big question here still. And regarding your question on how this could be applied in Singapore, I think there shouldn't be any big challenges in doing that. Of course, you may have some specialties in your place, like we have. Ice breaking is one of our elements that is essential to have, and maybe that you don't need, but maybe you have something else that is very important for you, like the traffic is much higher in your area compared to our fairways. Thank you.
I have one more question over here.
Hi, thank you for the presentation. Very insightful. My question was that some of the studies on autonomous ships state that where if there's a heavy traffic area or zone, the autonomous ship would be better off remote controlled. So in your case, do you either assume that there'll be all autonomous ships in that smart fairway, or if an autonomous ship enters the fairway, it is taken remote controlled by one of the entities that you mentioned? Thank you.
Oh, thank you. Quick question. We have been discussing a lot on this issue, so that we see that in future there will be different levels of automated ships in the fairway, and we were discussing whether we should allow some ships would be given preference over the others. But then I think it's the legal issue that we cannot, all the traffic is equal, so we have to serve all of them as they are approaching. And then I know perhaps you are asking related to this remote piloting, if the autonomous ship will be taken into control by the remote control center. That is something that we didn't take any decision in our study so far. But that's certainly a good question. Thank you.
Thank you, Marikka. I believe there are no more questions from the audience or from online. So thank you.